Hey there kids, welcome to another lesson. This is Module 2, Lesson 6, and it piggybacks on Lesson 5 where we are learning the standard algorithm, and it's really an awesome time in Eureka Math or in 5th grade, however you want to look at it, but we are learning to multiply using the standard algorithm, but kind of as a scaffold to help you learn it, we have these area models that will help you think. So this is kind of bridging from Lesson 5 to Lesson 6. We have problems from yesterday or from the previous video were so simple. It was like 12 and 21 and 123, so it was really small digits. There was no regrouping. If we were to continue using the area model from Lesson 5, then you would have only 2 sections. And so what happens is sometimes you have bigger numbers where you'll have regrouping. So say 4 times 3 is 12. What would happen is that you'd have to carry the 1 so that you could then calculate 4 times 7 is 28 plus 1 is 29. And it might be a little bit harder if you only had this 2-box model. So with the standard algorithm, hopefully you're catching on. It's still really easy. We do the same thing, and we'll talk about each one as we go through within the lesson. In Lesson 5, there was no regrouping, but in Lesson 6, yes, there is. And so the old model doesn't really help us as much as the new model does. And so in the new model, we're going to take apart each place value position and multiply it independently just to kind of help you. And we only use it for a couple of days, really, with this program, so that you're using the distributive property to get those zeros, because it's really, really easy to add when you have like just a simple quick fact like a 4 times 7, which is 28, and then tack on that 0. 3 times 4 is 12, so we're separating the 3 ones from the 7 tens that we had up above. Okay, so that's the purpose of this new model, is to separate everything out. Look at when I'm multiplying the tens by the tens. 7 times 6 is 42, and then I have the 10, the 0 from this 10, and the 0 from this one, so that I end up with 4,200. It's going to be easier to calculate and get this. It'll be easier to calculate and get 3 times 6 is 18. Tack that 0 on for 180. Then you can add these two partial products to help you get your first partial product from the standard algorithm. Okay, here's yet another one with 3 digits times 2. And so if you have 814 times 39, you can have the 3 digits going across the top and the 2 digits going on the side. Remember that the tens is on the bottom and the ones is on the top. And that the purpose of the ones being on the top is because the first partial product is going to be with the ones that are in the lower right-hand corner. Sometimes students will want to flip these around so that 39 is on the top and then the 814, all kinds of different configurations. And I'll say, no, no, no. And you know if that's you who I'm talking to. But anyway, nope, we want to have only the 2 digits on the bottom so that you only have to have 2 partial products. Otherwise, you'd have to have 3 lines of data, and that's just a lot more stuff to worry about. So those are your notes from today. Hopefully you got those. And you can always go back and pause the video if you didn't. But let's jump in, and Lesson 6 is a good one. It doesn't take too long, and it's just more of that same standard algorithm. We're going to draw an area model. We're going to solve using the standard algorithm. We're going to use arrows to match the partial products. Okay, just like we did in Lesson 5. So 48 times 35. Let's try, well, when you have your numbers on the top and the bottom, we want to have the 5 in the ones place on the side. Okay, so we're going to use this 35 on the side, and we'll put our 40 and 8 on the top. So make your model, have your box. If you don't set it up like this, you won't end up with the 5 in the ones place, so you may not have these matching partial products. And that's the whole goal of today, is to match them. If you were to have set up 48 here and 35, it would come out kind of wickety-whack, and then you'd have to redo it because you'd be like, I don't know why these don't match, and then somebody might cry, and then that would stress everybody out. So anyway, let's do this. 5 times 40, well, 5 times 4 is 20, and then bring the 0 down. 5 times 8, these are just ones, so it's 40. So I expect my top partial product to be 240. That's my expectation. 4 times 3 is 12, and I have 2 zeros, so 1200 because it's 40 times 30. 8 times 3 is 24, but whoop, bring over that 0. And then adding these, the only place where you have something in common is in the hundreds place. So I've got 40 for my ones and tens. Then in the hundreds, I'm going to have 4 because it's 2 2s and then a 1. So that's my expectation for my two partial products. Let's check it out. 8 times 5 is 40, carry the 4. 5 times 4 is 20, plus 4 is 24. Look at that, they match. If you don't match here, go back and figure out what your calculation error is in here. Next one, and again, because this is 5 ones times 48, that's the partial product right here. The next one, if you remember from the previous video, you have to hold this spot with the 0. Okay, you're going to leave it there because we already multiplied with the ones. I need to multiply with 3 tens or 30 times 48 to get my partial products to go here. Starting with the 3 in the tens place, your first digit from here, not the 0, is going to be the 4 from 24. 3 times 8 is 24. The 4 goes here in the tens place. Carry the 2. Done with the 4, so you can cross it out. 3 times 4 is 12, plus 2 is 14. 14, the 4 goes here, and the 1 goes out here in a separate place value position. Don't try to cram it all together. That's 1440, and it matches our partial product. Look at, we used arrows to match. Now let's add. 0 plus 0, 4 plus 4, 4 plus 2, and the 1. And so your first answer or final product would be 1,680. Okay, you can add these two if you want to. It doesn't really force you to do that in the, I think in the prep book, but you can do it just to compare and see that you're going to get the same answer. But it's going to be from these here, and it won't necessarily be from these. I think what you find out if you add these up, and if you've flipped things around, then you'll get some of the partial products from flipping. Anyway, that's a story for a different day. So let's do 648 times 35. We're going to take our 648 and stretch it out across the top, breaking it up or distributing each place value position. 6 in the hundreds place, 4 tens is 40, 8 ones. Break that up. We need 2 rows because 30, remember, on the bottom, and 5 ones on the top. Okay? Then make lines, these sections. Now, you can start with this and then work your way over. So 6 times 5 is 30, and then we have 2 zeros. So 600 times 5 is 3,000. 4 times 5 is 20. We have 1 0. And so 5 times 40 is 200. And then 8 times 5 is 40, and that's just ones. Okay, 6 times 3 is 18. I have a 0 from here, and I have 2 zeros from here. So don't skimp on the zeros. 3 times 4 is 12, and then 1 and 2 more zeros. 8 times 3 is 24, and a 0. So when you put together your partial products here, it's going to be 3,240. And that's my expectation for this first partial product. Say that 10 times fast, I dare you. I know everybody's doing it. They're like, oh, first partial product. Okay, yeah, I can't even say it 1 time slow. Okay, now in here, watch out for the columns that will have numbers that you will join. So I have zeros all in the ones, and then 4 tens, so it's going to be 0 in the ones, and then 4 in the tens, and there's no other tens. Okay, but then we get to the hundreds, and we have 2 here and 2 here. That's 4. That's the only one for hundreds. And then we have in the thousands place, we have the 8 here and the 1 here, so that's 9. And then in the 10,000s, we have 1. So that's my expected partial product for the second one. Now let's use the standard algorithm. Okay, 5 times 8, 40. Be neat and line things up very carefully. 5 times 4 is 20, plus 4 is 24. 5 times 6 is 30, plus 2, 32. 3,240, 3,240. Hooray! Hold this spot with a 0 because we're done with the 5. Now we're moving on into the tens place, so start in the tens. 3 times 8 is 24, carry the 2. 3 times 4 is 12, plus 2 is 14, carry the 1. And then 3 times 6 is 18, plus 1 is 19. 19,440. Hooray. Now these match, so I'm going to go ahead and add. Zeros, 4 plus 4 is 8, 4 plus 2 is 6, 9, 10, 11, 12, carry the 1, and then we have 2. 22,680. And if you were to add these, 0 ones, 8 tens, 6 hundreds, 12, carry, and then 22,680. So those match too. Okay, so those are the standard algorithm with the area model. Now that you are a pro at the area model, guess what? You don't have to use it anymore. Don't you love that? They're like, now that you're good at it, let's drop that. Okay, so we're going to take these apart with the standard algorithm, so using the ones place and then the tens place to multiply, not taking apart each of these digits with the hundreds, but technically as we're multiplying through, it's going to be just like taking it apart one digit at a time. Give lots of space for yourself here as you write the standard algorithm. Okay, so start multiplying with your 2 ones. 2 times 8, 16. Carry the 1. Carry it over to the next digit because it's going to be 2 times this, 2 times this, 2 times this. And that's how you do it every time. When you go to here, you're going to go start in the ones, then the tens, then the hundreds, in that order. Now that I've done the ones, 2 times 8 is 16, carry the 1. 2 times 5 is 10, plus 1 is 11. 2 times 7 is 14, plus 1 is 15. First partial product, you should have 1,516 for the first line, or 1516. Sometimes I just will say the digits because it's like easier for me. Anyway, first digit in the ones place should always be a 0 in row 2 or the second line of data, because now I'm using 9 tens. So 9 times 8 is 72. 2 goes down, 7 goes up over the next digit. 9 times 5 is 45. 45 plus 7. Don't forget that all these on top we're adding. That's going to be 52. And then 9 times 7 is 63 plus 5, 68. And then we add these. And so you should have 68220 as your second partial product. Now add these. 6, 3, 7, 9, and 6. 69,736. And hopefully you got that too. Let's do another one. 958. Again, give yourself some room. Don't cram it all in together. Times 94. You know what they're checking today? They're checking to see if you know your nines. Do you know your nines times tables and your eights? This is a big check for you. And your fours. 4 times 8. 32. You should have a chart handy if you don't have your multiplication facts memorized. 4 times 5 is 20, plus 3 is 23. And then 36, 4 times 9 is 36, plus 2 is 38. So 3832, or 3,832 for your first partial product, which is 4 times 958. Next one, we're done with the 4. Hold this with a 0, go to the tens place, and start multiplying. 9 times 8, 72. Carry the 7. 9 times 5 is 45, plus 5, 52. Notice that sometimes I just write right over the top of my little carried over digits because I don't have very much room up there. 9 times 9 is 81, plus 5, 86. And then we're going to add those. So you should have 86220, or 86,220. Now add, 9 and 10. And you should end up with 90,052 for your second for B. Next one, 476 times 65. 5 times 6 is 30. 5 times 7 is 35, because it's one more 5, plus 3, 38. And then 20 plus 3, 23. Hold this with a 0. It's like a ghost 0. It has to hold that space. Some people leave it blank. That's fine. 6 times 6 is 36. The 6 goes down, the 3 goes up. Look, it's already there. I think I'll use it again. 6 times 7 is 42. 43, 44, 45. Now I need a 4 up here. 6 times 4 is 24 plus 4 is 28. So your partial products should be 2, 3, 8, 0 on the top, and then 2, 8, 5, 6, 0 on the bottom. Now we're going to add those together. We get zeros. 8 plus 6 is 14. 5 plus 3 is 8, plus 1 is 9. 8 and 2 is 10. And then we end up with 30,940. Hopefully that's what you got at home. And the last one with the standard algorithm and no words, 547 times 64. Give yourself lots of room. What do I keep saying? Don't smash it together. 4 is your first factor, 4 ones. 4 times 7, 28. 4 times 4 is 16 plus 2 is 18, and then 21. First partial product, 2188, 2,188. Hold this spot with a 0. Or just put your first partial product for the second one in the 10 space. 6 times 7 is 42. 2 down, 4 up. 6 times 4 is 24 plus 4 is 28. Carry the 2. 6 times 5 is 30 plus 2 is 32. Second partial product, 32820. Or for those of you who don't put anything, it's 3282, but 2 in the tens place. Add these up. 8 and 0. 8 and 2 is 10. 8, 9, 10 again. 2, 4, 5. And the 3 comes down. 35,008 is your answer for D. Now, let's do a couple word problems. We're going to apply this skill. Carpet costs $16 a square foot. A rectangular floor is 16 feet long by 14 feet wide. Now, these are this is how you write it if you want to find out how much would it cost to carpet the floor. If you want to figure out carpet or sod or anything that's laid out over a flat area, then you're basically trying to find the area of that space. And when you find area, it's length times the width. So if it's length times width, it's how many long by how many wide. Then in order to find out how many total square feet, you have to see the 16 this way and the 14 that way to find out the total number of squares. And I actually did that one year, and this is what it looks like. 16 feet by 14 feet. And so you have actually a whole bunch of squares. So how many total squares do I have to come up with at $16 a square foot? So let's do the multiplication to find out how many square feet we actually need. 16 times 14 is how we get started with that. 4 times 6 is 24, and then 4 times 1 is 4 plus 2 is 6, and then hold this with a 0, and now we have 1. 1 times 6 is 6, and 1 times 1 is 1. We already used the 2, so don't calculate it again. And then add these. 6 and 6 is 12, and so you end up with 224 square feet or feet squared total, and that is the rectangular floor. All those little boxes that were on that picture, it's 224. See, it adds up. So now I'm going to take the 224 square feet because each of those squares is going to cost $16. So you take your 224 square feet times $16 per square foot. So let's find out how much it's going to cost to carpet the whole floor. 6 times 4 is 24. Then 12 plus 2 is 14. Then 12 plus 1 is 13. You should have 1344 or 1,344 for your first partial product, which is 224 times 6. Second partial product, hold this spot with a 0 because it's really for the 10. 10 times 224, so just put the 0 there so it's at the end. 1 times 4 is 4. 1 times 2 is 2. 1 times 2 is 2. And you could have just said it's going to be 2240 because it's 10 times 224. And yes, it is. So now we can add these two partial products. 4 plus 0, 4 plus 4, 3 plus 2, and 2 plus 1. Now what were we looking for? We were looking for cost. How much will it cost to carpet the floor? Because this is money and this is the square feet. It will cost, or it would cost, $3,584 to carpet the floor. Always write your answer out when there is a word problem. Read, draw, write. Okay, that's our strategy, always with word problems. There are 2 more. Do not go away. 2 more, here they come. General admission to the American Museum of Natural History is $19. Ouch, that's a lot. If a group of 125 students visits the museum, how much will the group's tickets cost? So if I have a bunch of people, 125 to be exact, and each one is going to be 19, I will have to multiply to find the total cost for everybody. 9 times 5, 45. 9 times 2, 18. 19, 20, 21, 22. 9 times 1 is 9, plus 2 is 11. 1125, first partial product. First thing, what do? Put the 0 there so you don't forget. Now it's 1 times 125. I know it's going to be 125, okay? But I'll go through the motions. 1 times 5, 5. 1 times 2, 2. 1 times 1 is 1. Ta-da! We did it. And let's add 5 plus 0, 5 plus 2, 2 plus 1, 1 plus 1. Oops, 1 plus 1. 1 plus 1 is 2. How sad. I was just saying 1, and I was thinking 1, and then I said 1, and then I wrote 1 instead of 2. So $2,375 for the cost of all the tickets. That's not too neat, but there it is. Okay, so let's do the last problem, which is actually still part of number 4. So if the group also purchases IMAX movie tickets, we did that one time, for an additional $4 per student, what is the new total? Okay, we need a new total cost, but we also need to write an expression that shows how you calculated the new price. So when you're calculating from the previous problem, and we used 125 times 19, but 125 is the number of students that we also have to multiply by 4. You can just take that 125 students and you can multiply it by the cost of the museum tickets and the cost of the IMAX tickets. Now this is one way to write this out. This is an expression that will work. Remember that this dot is the new way to write your multiplication sign. That's how the upper grades use multiplication, because an X looks too much like a variable. So you can do that, or you can multiply this times this like we did up here, and then put a plus, and then you can add the calculation of 125 times 4. So 125 times 19, this is what I'm talking about, plus the 125 times 4. But it's like you're trying to save yourself from writing so much, the 125. And since we already calculated the 2,375, we just need to know what the 125 students times 4 is, $4, in order to get the additional cost so we can add it to what we already had. So 5 times 4 is 20, 4 times 2 is 8 plus 2 is 10, and then 4 times 1 is 4 plus 1 is 5. So this is going to be additional dollars. And since we already had the 2,375, then we add our 500, and we get 2,875, which is our new total cost. Click subscribe and come back again, and I hope I can help you on future videos. I hope this lesson was fun for you, and I will see you real soon. Take care. Bye now.